This is an example of a problem where they give us sort of a real world context and want us to understand how that real world context plays out in terms of a specific derivative that they're asking us for right here. So let's take a look at what they're telling us. So the height above the ground of a person riding a roller coaster t seconds, we always got to figure out what our variables mean, is modeled by the differentiable function r. Differentiable function in this situation is really just saying to us that we can take the derivative of it. It really doesn't mean a lot to us other than the fact that it's saying you're allowed to take the derivative of it. And so what we're finding out at the end here is that the height above the ground is modeled by this function r. So the y values that come out of this, the answers that come out of this equation are the height above the ground. Whenever I go to determine what a derivative means, because that's what we're being asked about right now, is what does this derivative value mean at this specific point? I always go back to just the stuff that I understand the best, which is the notation dy dx. So what that means is the change in our y units over the change in our x units is what we would be looking at here. And so as you talk about r prime of 5.5 is equal to 13.597, let's change this notation to kind of fit the language of our problem. So dy dx would be dr, because those are our y values in this situation, and we're talking t, we're talking time, so dr dt. And so what we know now is we're looking at the change in our r units. And so the change in the R units again is height above the ground, and then it's being measured in feet, right? So we are talking about R of t is measured in feet. So the change in feet per, and then it's going to be the change in our t units. Well, the t units in this one are t seconds. So this is feet per second. So what you can say about this is on this side right now, this is 13.597 feet per second. That's going to be the units for that number right there. And then what we're plugging in this is our t value right there. So that's telling us t is equal to 5.5 seconds. So at this moment in time, we're changing at 13.597 feet per second. And because it's a positive derivative value, we know that that's telling us that this is increasing at that rate. So now we've deciphered all the information that we have in front of us, and now that we know what it's saying, it's pretty straightforward to come through and see that the person's riding height above the ground is increasing by 13.597 feet per second. There's our units that we were looking at. And then at this point, 5.5 seconds after the ride begins. And so our answer on this one would be answer C. When you're looking to find out what these things mean, I always find it helpful again to go back to something you're familiar with, dy dx, which is telling us the change in y units over the change in x units. And then turn that little sentence into what fits the language of your problem, and it should be pretty straightforward to find the answer. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.